Today, mathematicians, thank you. We are going to multiply by using the standard algorithm. So we practiced multiplying using the open array, and we've done a lot of good work with that. But I want to teach you the standard algorithm because it's something you're going to use the rest of the time in your math, but it's also a little bit quicker, okay? There are a few things we need to remember about the standard algorithm. I'm going to talk to you about those today. The very first thing we need to think about is place value, okay? Place value is so important in the standard algorithm. You're going to see that it's similar to the open array, it's just a little bit quicker, okay? So when we look at this problem, this is a pretty simple problem, we need to look at how the problem is set up, okay? This is called stacking. When you do the standard algorithm, you stack the numbers. Just like with subtraction, the bigger number needs to be on top, okay? Always, always, the bigger number. Whether it's a 2-digit, 3-digit, 4-digit, it doesn't matter, but the bigger number needs to be on top, okay? So we're going to think about place value. And in this problem, we have 12, which is in the ones and the tens place, and we have 8, which is in the ones place. So this is a pretty basic problem. So when we do the standard algorithm, we multiply the numbers together. So we're going to start in the ones place. So 8 times 2 is 16. So I write my 6 here, but then I have to carry my 1 because it's in the tens place, correct? Just like when you add, it's the same exact thing, but we're multiplying. So I have to carry my 1 over because now it's in the tens place. So we went here, now we're going to go here, right? So we multiplied straight up, now we're going to move over. 8 times 1 is 8 plus 1 is 9. And just write your 9. Well, what's 12 times 8? 96. Okay, question?
Well, I thought it would be like, because 8 times, but because that 1 is in the tens place, I thought it would be 8 times 10.
Okay, let's see. What is 8 times 2?
16.
What is 8 times 10?
80.
80.
Oh.
See? That's what we did. You just did it without having to break the number apart. When you do an open array, don't we write 10 plus 2 and 8?
Mm-hmm.
80, 16. We did 8 times 2, which was 16. Instead of writing the 16 down here, we wrote the ones place and we carried the tens place. 8 times, it's not 1. Jordan's exactly right. It's what?
10.
It's actually 10 because it's in the tens place. 8 times 10 is 80 plus 1. Okay? That was a perfect question because that helped us understand, oh, do you see why I said place value is so important? It's not 1, it's actually 10. Okay?
Well, didn't we learn this in 4th grade as just regular algorithm?
That's what it is, the standard algorithm. That's what it's called, the standard algorithm. Most of you have probably already learned this.
You aren't actually adding 1, you're adding 10.
Right,
Because if
good.
you're adding 1, it'd be 80.
Okay, perfect. Thank you. That is a good point that she made. We're not adding 1. I talked about how place value is important. We're adding 10 because it's in the tens place. We actually added a group of 10 to it. Perfect explanation, okay? We say add 1 because that's what we're doing. But in all reality, what are we really doing? Adding 10 because it gives us 90, okay? So now that we've talked about how place value and how it's so important, we're going to try another number, but we're going to try a 2-digit by 2-digit, okay? I'll just use my hands, I don't have an eraser. So, once again,
Switch over the board.
we need to think about place value, okay? So let's do 13 times 22. Now, earlier I said bigger number has to be on top. What I meant by that was the bigger number that has the most digits. Okay, 22 is bigger than 13, but they have the same number of digits. So the number that has the most digits needs to be on top, not necessarily the biggest number. Okay, so I need to clarify that. So 13 times 22. Let's think about this. This is 10 and 3. This is 20 and 2. Correct? But when we do the standard algorithm, we just think of the number as the number. So 2 times 3 is 6. That's in our ones place because we are still in the ones place. So now we went up, now let's go over. What's 2 times 1? 2. Put it in our tens place because I actually multiplied by 10, not just 1, correct? So think about it. What is 13 times 2? 26, correct? Okay, so we've taken care of the 2 in the ones place. Now we've got to move to the tens place, okay? So how we do this is we need a placeholder, something that holds our place. Are we in the ones place anymore? So am I going to write my number in the ones place? No, so I have to put a 0 there. Think of powers of 10. When we multiply by powers of 10, what do? You add a 0 and you move over a place, right? Well, we just moved over a place. So we're going to put a 0 there because it's 10 times greater exactly, and that's going to hold our place. So we now know we can't put a number there because we're now in the tens place because we're actually multiplying by 20, not just 2. So think about it. What's 20 times 3? 60, right? So if I put my 6 there, what do I have? 60. See what that 0 does? But instead of thinking 20 times 3, we can think, oh, what's 2 times 3? 6. But my 0's already there. It's actually 60. Okay? Now, this one's in the tens place, and this one's in the tens place, correct? When you have 10 times 10, what do you have? 100. So now we're in the hundreds place. Where am I going to write my number? In the hundreds place. What's 2 times 1? 2. But it's actually 20 times 10, which is 200. See why that's in the hundreds place? Okay, so we have partial products. We did 2 times 13, and we also did 20 times 13, correct? Here and here. So when you have partial products, you have to add the total up. So 6 plus 2 is 8, 286. Okay? Let's try one more. I know, that's okay.
Okay. Can you grab your eraser?
That's alright. We're just going to do one more. 125 times 61. Okay. Where are we starting? In the ones place. 1 times 5 is 5.
You should just write the whole
Now,
number over since this
1 times 2 is 2, but it's really 1 times 20, so it's going to go in the tens place, right? Which is 20. It's in the tens place. 2 in the tens place is 20. 1 times 1 is 1. But this is actually 100, so 1 times 100 is, and it's in the hundreds place, correct? See why place value is so important? You have to think about the place value. You can't just think about the number. So, that's partial. That's part of my product. Now I've got to take care of the 6 or the 60. So what do I need to do? I've got to place a 0 there. It's my placeholder. I'm no longer in the ones place. I'm now in the tens place. So I have to put a 0 there. This is the biggest mistake that friends will make is they won't put the number 0 there to hold their place. Okay?
Sorry to interrupt you. These were from Lance, and I forgot to give them to your kids.
Okay.
One to each person, and these have names on them.
Thank you. Okay, so 6 times 5 is 30, which is actually 60 times 5, right? Which would be 300. That's why I'm going to place my 3 up here. I have to carry my 3. So 6 times 5 is 30. I brought my 0 here, but I carried my 3. What's 6 times 2? 12. So I'm going to write my 2 here. What am I going to do with my 1?
Carry.
Carry it, right?
What about that 3?
Oh, sorry, thank you. Okay, 6 times 2 is 12, plus 3 is 15. Okay, carry my 1. 6 times 1 is 6, plus the 1 is 7. Okay, so there's my partial products. Let's add them together. 5 plus 0 is 5, 2 plus 0 is 2, 1 plus 5 is 6, 7. Okay, do you see how this is a lot quicker than drawing the box and adding all of the partial products together and then adding them up? Okay, you're just doing the same process, it's just a lot faster. But you have to pay attention to the place value. Okay, also when you do the standard algorithm, make sure your numbers are lined up. If I'm working in the ones place, I've got to put my number in the ones place. Okay, if your numbers are not lined up, you're not going to get the right answer. Also, there's lots of reminders. You can do everything just right, and then you get here and you add incorrectly. Your whole problem is going to be wrong because you didn't add correctly. Make sure you're very, very careful in this process. You write neatly and you add correctly, okay? When we do the standard algorithm, we're going to check it with the open array until we get really good at this. So we can make sure that our answer is right. So for the next day or so, we're going to practice the standard algorithm, check it with the open array, and then you also have to check it with the inverse operation, right? And that will guarantee that we have the correct answer.